Hello and welcome, fellow programming friends. Today we will rewrite the game Conway's Game of Life in JavaScript. For those of you who are not that familiar with the game, I will summarize it real quick for you. For the other ones, yeah, we all need to get through this. Just kidding. So basically what we have an initial population. Let's say we have a two-dimensional grid, so an Excel sheet basically, and there are little squares, and if the square is alive, it gets the color white, for example, or on the right section it's got colored green, and this says it's alive. And yeah, we have a random grid for the beginning, then it involves, and evolve means based on the 4 rules we will talk in a second, we decide how the next generation will look like. So what will happen? The first rule says that a dev cell will come back to life if there are exactly three living neighbors. And in this example we have a grid of 9 cells, and the center one is black, it's dead, and we can count the green living cells around it, it's 3, and in this case, in the next generation, the center one would be green. Then there is the second rule, and the second rule says that this center one, a living cell with less than 2 living neighbors, will die. So 1 and it's gone. The third rule says that a living cell with 2 or 3 living neighbors will live into the next generation. The fourth rule says that a living cell with more than 3 living neighbors will die in the next generation. So how can we realize this? We just create a 2-dimensional grid in JavaScript and randomize, populate it with some values between 1 and 0, 1 for dev, 1 for live, 0 for dev. Very simple. And then we use the P5 game engine. I found it and I like it and I want to learn it, so I use it this time and draw what we want to see, basically dead or alive cells inside a grid. And then we will iterate to the grid and check based on the rules how the next generation will look. So let's get started. Create a web server first. You can use whatever you want, and you can also do this in every language you want. Maybe you want to use Python or C++. It's also working as a console app if you want. So basically, I will copy this from my GitHub. You can download it. I will have the link in the description. What we are doing, we are loading the web server Flask and also its render engine, and then we render the HTML template, and inside this template lives the canvas that's got created by the P5 game engine. So next we need to create the templates folder. Inside this will live the HTML template. Let's call it index.html, and also copy and paste its content. What we are doing, we are inviting our style sheet, the game engine, and our game code. For this we need to create a static folder. From this the files get served. We have CSS inside this. Let's create the folders first. We have also JS, and here we have the lib, and inside lib lives the P5 game engine. Let's copy this first. Again, all my GitLab. What I'm doing now, I need to create the script file. This can keep empty for now, and then I write the style. Let's copy this as well. So what we do here, we give the canvas a white border and make it a little bit round on the edges. Then we give it a little bit padding, everything in the body, and also make it black so our eyes don't hurt. The background, I mean. And I will probably make the game as well white dog. Let's close this. We don't need this. Talked about this. Nobody needs this. Talked about this. Yeah. You can use, as I said, whatever I want. So first we need to set up the game engine. It's a built-in function. And we need a game loop. Also a built-in function, I guess. Yeah. So who cares? Actually, let's create a canvas. And let's say it's 640 pixels wide and have a height of 480. This should look good. And let's check first if the server is running. This looks good. Let's verify we load everything properly. We have a black canvas and no errors. This looks ugly. Let's do this again, but this time the other way around. Yeah, better. So the resizing, I don't want to mess. It's easier this way. We all know this problems of fluxes. So what do we need next? We need to say how big will our cell be. So let's say let size equals 20 pixels in this case, and we also need to specify the size of our grid. And for this I can use the width and the height and use the size to decide how many columns and rows we will have. So say let cols, let this simply be as it is, and we probably need something to store our grid. This looks okay. Now we need to calculate our columns. For this we take the width and divide it by the size and do the same for the rows, but we take the height, it's 480, size. We also need our grid to draw, so we need a grid. So we can say grid equals create grid. We need to write this function, of course. And what we are doing, we are creating a two-dimensional array. Very simple. Say let new array, yeah, not array, grid equals new array. Let's have it with columns. Now we can say for I equals 0, I less than columns, incremented. Now we say new grid I equals new grid. So basically not grid array, there is a second array inside the first array. And now we need to give it some initial values. So basically say if it's dead or alive, the cell. So for let, I see an error here. This is let I. Probably would work anyways, but keep it safe. Let j equals 0, j less rows, j plus plus. Now we can say not grid, new grid ij equals, we need a value, and guess yes, because I will get a float here, random, and 2. This should give me a value 1 or 0 and a 50-50 base. And let's return this little sucker. Let's verify it. Let grid new array, then we go through it. I say new array, go through it, give it some value, and return it in the end. Okay, now we are ready to draw it, but let's set a background for it so it's a little bit lighter. And then we need to look at every cell in our population. For let I equals 0, I less. Oh, this song is hard. The male dance. I don't know the song, but it's nice. It's very, very heavy. Okay, for let less columns, I plus plus, incremented the same. Let j equals 0, j less rows, incremented again. So we touch every cell. No, not if the cell or the cell, it's in our grid, it's ij. This is what we are looking for. Wrong brackets equals 1 if it's alive. Now we say, yeah, of course. Give me the wrong value, give it me back. I hate to set it for this behavior. Yeah. Now we want to draw the cell as a rectangle. For this we need a start value, actually 2 start values, the top left and the bottom left. And for every cell, this lead is, whoa, this song is even, this is crazy. We need a point where we start, so we can grab this if we look at our size and the current index of our grid. So say let x equals I times columns and let y equals j times rows. Now we can say, okay, we have the top left and the bottom left, and we want to draw for size. And I also want to have a little border. For 1 pixel should be enough. So say x, y, size -1, and again size -1. Let's have a look. There's an arrow. What's saying stroke is not defined? Yeah. Soak is not defined, or however I spelled it. This looks okay. So we have a random grid. Let's do it again. Yes, nice. Now we need a next generation, and we want to build this next generation based on the rules. Yeah. Let next, no, that's enough, equals create a grid. We grab a random grid with random values. It's fine. I don't want to make an extra function to make it that or whatever. It's enough. It's okay. So next we need to iterate again through our grid with the nested loop. Let's copy this. And here we have to look if it's alive or dead. Yeah, that's one part of the rule set, but the bigger part is the neighbors we need to count. So when we look back here, we count our neighbors, and we are the center cell now. The black here, I guess this is better to see. We are this little population, and we're the black center cell, and we need to look at this. And how can we do this? We have a grid that's a 2-dimensional array basically, and we can say, okay, we are inside it, somewhere inside it, and we want to have 1 up and 1 left. So basically what we are doing, we say -1 and -1 because we are coming from top right and go to the bottom right, top left to the bottom right, like you read. And to achieve this, we can iterate with a for loop starting with -1, going up to including 1, and we need to take care of an edge case, and that's basically if we are on the edge, then -1 is an invalid index for an array, and in this case we can use a little math trick to jump to the opposite side of the grid. By this we make basically an infinite grid, and yeah, let's write this. And also while we are doing this, we will look for the leading cells, and it's 1, so we want the sum of it, so we can basically add it together. This is let neighbors, I don't know how to write this word correctly. Let's say count neighbors. And what this needs, it needs the current cell we are looking. Yes, so basically I and j. Let's create this function, and let's say this is our x and y values in our grid. I like it from us. So now we can say our sum is 0. Let's always start with 0 and a new value for it, so we don't overwrite something. And now we can do what I said with for I, say for let I equals -1, I less 2, I plus plus. -1, 0, 1. These are the values we are looking with into our grid or to our neighbors. And the same for let j equals -1, j less than 2, j plus plus. I talked about a little math trick. It's functional. We use the modular operator, and we will get back the remainder, and this can be used to jump to the opposite of the grid. You can use it in other different scenarios. It's more useful than you think. So how can we do this? We are looking for a neighbor in our cell. We are looking for the neighbors of our cell inside of our grid. So we need to define the current cell we are looking for, basically a new x and y value based on the cell we are starting with. So say let col equals, and now we combine everything we are talked about. So for reason you can give it into the console and or listen to my words and count it in your head. It's very simple. We say I plus x. So for the first example, let's say we are in this edge case. What happens? We have I with -1, we have x with 0, and by this we have a negative value and indexes, as I said, can't work with this. But we can add to this value our columns in this case. Let's say we have 20 columns, and then we get a value of 19. And when we say, okay, we make the modular of this, we will get back 19. And in this case, we jump to the opposite side of the array. And the same obvious for rows. J plus y plus rows and mod rows. There is an S missing. So now we know what neighbor we are interested in exactly. And we can say sum plus equals. And we take our grid, say column, row. And now we also have to keep in mind we are looking for living neighbors. By this we are also going over the point 0, 0, what we are. It's basically the xy value we give as parameters to this count neighbors function. So we need to subtract ourselves. If we are null, nothing gets subtracted. If we are 1, this gets subtracted and everything is fine. It's negative equals grid x, y. We are looking for ourselves now. Now we can return the sum. By this we should get all our living neighbors. And we can use this here. So now what we do, let's make this new line vanish. Now we can apply the checks for our rules. So say if the cell we are interested in, the current cell is alive in this case, is 1, and this is the first rule here on top. We are, sorry, not 1, 0, we are dead. And 3 neighbors, exactly 3 neighbors are alive. Then we come also back to life. And this got realized by this. So say no, not grid, it's next in this case, because I don't want to change the values of the grid I'm working with, because I need them. I need them to stay. So say 1. And here's an error. Yeah, I forgot those. This is the first rule. The second rule, and here we can combine the rule, I guess it's 2, yes, 2 and 3, with less than 2 will die and more than 3 will die. So else if This time the grid is, or the cell is alive. And we have as close to no neighbors, and we're lonely, and we're going to die because we are lonely, and loneliness kills people. And on the other hand, we have 3 because we don't like that much people, but the city is under pressure. I like the small village I'm in, and the city next by. It's the best of both worlds. So in this case, next will be dead. He's gone. Gone's to the land of the daddies. Otherwise, next IJ will be nothing. Will be will be whatever grid is actually. So we don't have the need to change. And now we can override our grid so we can display the next generation. So let's go over it real quick. So maybe there's an error and try to catch this. We get our neighbors, it should work. So if grid, if the current cell is dead and the neighbors are exactly 3, then we are alive. Otherwise, if we are alive and the neighbors are less than 2 or bigger than 3, we are dead. This is also next, yes. And else next is grid. Okay, this seems to look okay for me. Let's give it a try. Yeah, it's evolving. The cells are working. And I guess now we got stuck. But yeah, basically that's it. That's Conway's Game of Life. Let's play it again. So now you can feel free to evolve the project to make it a little bit more interactive, and you can do really nice things with it. And the other thing you can do, you can just watch the next video where I do it for you. But I highly recommend you to do it by yourself. But I had a lot of fun doing this now, so it's really interesting. So happy coding, and thanks for watching, I guess, and see you in the next video.